GameSci.com. GameSci.com. Welcome to GameSci.com. I am Professor Chris Ferguson. GameSci is where we learn game programming and computer science at the same time. This is CS1, Intro to Computer Programming. This course is a series of 10 lessons, and this is lesson. Since we will be building a simple game piece by piece, it's best if you watch the videos in sequence. While we build a simple game, you will also learn object-oriented programming and the important concepts of computer science. I am Professor Chris Ferguson. Enjoy the course. Welcome to Let's Learn Binary. Now, an understanding of binary is key to understanding how a computer works. Computers are binary machines. Everything a computer is, everything a computer does, is nothing more than zeros and ones. What I've got here is a listing on the left side of the screen that shows you that decimal and binary equivalents. You can see decimal 0, of course, is binary 0. Decimal 3 is equivalent to binary 0011. You can see decimal 8 is equivalent to binary 100. The thing you'll notice here about binary is it's composed entirely of zeros and ones. Nothing more, nothing less. Now, we as people, we like decimal or base 10 numbers. This means there's 10 digits in our numbering system, 0 through 9. This, of course, evolved because we have 10 fingers, right? Why would we use base 10 numbers when we have 10 fingers? Now, if you look closely at a decimal number, one of the things you'll see here is you can break it down. You remember in the 3rd grade when they taught you about the 6 was in the ones place, and the 3 is in the tens place, and the 5 is in the hundreds place? Well, a decimal number can be broken down with the following equation, right? It's 5 times 10 squared plus 3 times 10 to the first, plus 6 times 10 to the 0 power. What we've done is just broken down the number 536 into its components. Well, 10 to the squared is what? 10 to the squared is 100, right? So it's no accident that your 3rd grade teacher told you that the 5 was in the hundreds place, because 10 to the squared is 100s, right? That means the 5 is in the hundreds place, and that 5 represents the value 500 to the decimal number. Now, 10 to the first power happens to be 10. That's why this is called the tens place, and 3 is in the 10th place. That 3 represents the value 30 to the overall number. And finally, the 6 is in the ones place. Why is it called the ones place? Well, 10 to the 0 power is 1. So that 6 represents an actual 6, because 6 times 1 is 6. So this is how a decimal number is broken down into hundreds place, tens place, ones place. It's all based on powers of 10. Now, when you switch over to binary, computers like binary or base 2 numbers, right? That means everything is represented by zeros and ones. There's no 4, there's no 6, there's no 9 in binary numbers. You just get zeros and ones, right? Binary circuits are much simpler to build. They're much faster. They're much easier. Computers love binary. We as people work in decimal. Computers work in binary. Now, the binary 101 can be broken down the same way the decimal number can be broken down. That first 1 is 1 times 2 to the 2nd power, right? That 0 in the middle is 0 times 2 to the 1st power. And the one on the right-hand side is 1 times 2 to the 0 power. Right? The thing you need to notice here is these powers. In base 10, you raise this decimal place to a power of 2. Right? In base 2, it's 2 raised to that same power. Over here, we got 2 raised to the first power. Up here, look, it's 10, because it's base 10 numbers. Down here, it's 2 to the 0 power, because these are base 2 numbers. Up here, it's 10 to the 0 power, because those are base 10 numbers. Right? Base 2 numbers, we raise each place to the corresponding power of 2. Another way to look at this is, this would be the 0 column, the 1 column, or the 2 column. Now, in binary numbers, we wouldn't call this the hundreds place, we'd call it the fourth place. Why? Because 2 squared is 4. And this value of 1 represents a 4 to the overall value of the 1 number. Now, here is the 2's place. Why is it the 2's place? Because 2 to the first power is 2. However, finally, this is the 1's place. Right? Because 2 to the 0 power is 1. Anything to the 0 power is 1, to be honest with you. Now, if you look closely at the numbers, 1 times 4 is 4, 0 times 2 is 0, and 1 times 1 is 1, and this overall value comes out to be 5. Now, notice the arrow that I put in here. Right, that 101, binary 101, is the decimal value of 5. Right? Again, and it's 5 because that 1 there contributes 4 to the overall value, and that 1 there contributes 1 to the overall value. 4 plus 1 is 5.